name is Rohit Kumar Singh, and this is the 12th live session and the last live session for this course this semester. So today there is not much new to discuss because we have covered all the topics. Just some small topics remaining that I will try to discuss, and then we'll solve some more problems. Okay, and yeah, you can ask anything from the course that you have not understand, and we can discuss a bit more. So first, let's discuss what I intend to do today. So we have been discussing polarization so far, and so one topic left in the polarization is when you have some solution like optically active solution like sugar or something else, which can lead to phase retardation in the propagating wave. So what I mean, so the topic is basically optical activity in a solution, and this optical activity depends on the concentration of the solution. uh, so concentration, you guys know, right? Dilute and concentrate solution. If you have studied little bit chemistry, you should know what is concentration is. Basically it's mole per volume. I think exact formula I don't remember, but yeah, how many uh, how many moles of particular substance is there, of the solvent is there in per uh, yeah, per unit volume or something like this. Okay, so more the concentration is of a solution, uh, more optical activity will be there, like the phase retardation will be more. Okay, so we will consider an linearly polarized wave. Okay, you remember the linearly polarized wave. So we know that linearly polarized wave, so if it is x, this is y axis, it makes angle phi, right? Or let's say alpha for now. And for the linearly polarized wave, we wrote the Jones vector like this: cos alpha in x direction, so okay, this is y, then this is x, plus sine alpha y. So this is the linearly polarized wave, and so when it passes through an optically active medium, this plane of polarization, okay, this alpha, it changes. Okay, so the plane of polarization rotates. So when linearly polarized wave passes through an optically active medium, the plane of polarization, we call it pop, okay, it rotates. So this alpha changes. Now how do we understand this? Okay, so to see that, like I written above, linear we can see this through the Jones vector. So what is a linearly polarized wave? It is some combination of x polarized and y polarized wave, right, which is given by this in the Jones vector notation. And you guys know that x polarized wave can be written as superposition of what? Right circularly polarized wave and left circularly polarized wave, if you remember. So a wave polarized in x direction or in y direction is just a linear combination of right and left circularly polarized wave, right, given by this. So if you substitute these two here, and so okay, let me substitute first. RCP LCP plus sine alpha 1 by root 2 RCP minus LCP. Okay, and if you rearrange RCP and LCP, so take out RCP out, in the bracket you will get 1 by root 2 cos alpha plus sine alpha, it's a big bracket, plus if you take out LCP, what remains inside is half cos alpha minus sine alpha. Okay, so a linearly polarized wave is just a combination of right circularly and left circularly polarized wave. Okay, and this is the what you call components. I mean, this is a constant, so it doesn't matter. Okay, what is important is so linearly polarized wave can be seen as basically a linear combination of right circularly and left circularly polarized wave. Okay, so this is something that we also discussed earlier while we were discussing the Jones matrix. Now let's see what happens to right circularly and left circularly wave when it passes through a optically active medium. Okay, so now we go back to our wave notation. So let's have a right circularly polarized wave moving in z direction. Okay, so how do we write it? So x component, so this r is the notation for right circularly polarized. So x direction field is given like this: cos k kr z minus omega t, and the y component is given like this. Sorry, there will be a minus sign, if you remember. Okay, so for a right circularly polarized wave, this is how we write our this is how the electric field are represented. Okay, you can see if you square them, you will get a equation of a circle. Square them and add them. Okay, so yeah, this represents a right circularly polarized wave which is moving in z direction, and here this kr is the wave vector, r is for right circularly wave, which is given by w by c nr. So nr is the refractive index for the right circularly polarized wave for the RCP. Okay, similarly you can have LCP moving in z direction. So this will be given by similar formula: cos kl z minus omega t, and the y component will be, so here it will be positive. Okay, and this KL, the wave vector for LCP will be omega by C n NL. Okay, so this is the refractive index for LCP. Okay, now you have electric fields for RCP and LCP, and since we have seen here that the linearly polarized wave is basically the combination of these two, so let's add them to get our resultant fields. Okay, so resultant fields both in x and y direction. So in x direction we add these two. Okay, so what do we get? E naught will be common, cos kr z minus omega t plus cos kl z minus omega t. Okay, and so we can use the formula cos a minus b plus cos oh no, this is okay, both are, yeah, we can use the cos a plus b formula because here this is different from this. Okay, so we will get cos half of k l minus kr z and cos omega t minus theta z, and here the theta is basically half of kl plus kr z. Okay, is this fine? So we have used this formula, cos a plus cos b is given by 2 cos a minus b by 2 cos a plus b by 2. Okay, so yeah, so this is what we get for x component resultant field, and similarly for the y component you will get this sine half kl minus kr z, and here cos of omega t minus theta z. Okay, theta is same here. So now you see something interesting happened. Now the resultant fields, okay, so the original fields had x and y component, cos and sine respectively, right? But when we added them, now the time dependence, this factor you see here, it is cos in both the x and y direction, right? And this factor, which is just the amplitude, right, it has cos and sine dependence, but it doesn't have the time dependence. Okay, it is just the amplitude. Obviously the amplitude is getting changed because it depends on the z value which is changing, like which depends. So z is changing for each each moment of space, like each point in space, but it doesn't depend on time. So this is just this is just the amplitude, okay, variable amplitude, and the time dependent, so the wave so the wave part of it, both the components have the cos dependence. And what does it represent? If you have both x and y cos dependent or sine dependence, what do you get? You get a linearly polarized wave, right? So a linearly polarized wave have both the x and y component having cos dependence. Do you remember? You can check your
No.
notes.
Yeah, yes, sir. I'm checking that.
Yeah, you can check. Okay. And now this theta, and theta is same for both, right? Like and they are also in phase. So yeah, so they will be a linearly polarized wave basically. So what you get is basically a linearly polarized wave. So that means this rotation, okay, so the resultant wave is always linearly polarized with plane of polarization rotating, okay, with z. Now how do you know that the plane of polarization is rotating? Because the amplitude depends on z, so for both x and y, and we know that the this basically the okay, we have denoted it by alpha. So you remember alpha is given by tan inverse of plus minus a by b, where a is the a and b are the amplitudes of you know x and y fields, okay. So and since this depends on z, so we can calculate this, right? So alpha is tan inverse, so a by b is basically this quantity divided by that quantity, so it's tan of half kl minus kr z. So tan inverse tan will be just half kl minus kr z, okay. So you see this alpha depends on z, okay. So when when the wave is passing through the medium, it depends on how, like it depends on the z direction, okay, the angle that it is making. So you have this linearly polarized wave with this angle, and as it passes through the medium, this angle will change, okay, it will keep changing. So it is it will be linearly polarized, but the plane of polarization is rotating as it is passing through the medium, okay. And we can write it in terms of wavelength, because uh, yeah, because you know that k is just 2 pi by lambda, right? And if it is a refractive index is n, then this is the formula. So you can write this as pi by lambda nl minus nr z. So now you see it depends on two things. From here you can see it depends on the the basically the difference of the refractive index between left and right circularly polarized wave and the distance that is it is traveling z, okay, the longitudinal distance. So also you can write in terms of frequency omega, okay. So there is something called there are two types of medium. So if this NL is greater than NR, okay, the medium is called right-handed or dextrorotatory. Okay, and if NL is smaller than NR, then the medium is called left-handed or levorotatory. So it is little counterintuitive. You see, if the left circularly polarized refractive index is greater than right, then it is called right-handed, and if it is less, then it is called left-handed. So it is little counterintuitive, but this is the nomenclature. Okay. Now, why does it happen? So we understood why the linearly polarized wave will stay linearly polarized, but its plane of polarization will rotate from this mathematical construction we can see. Now, what is there inside optically active medium that does this? So if you take an example of a sugar solution, sugar you know well, right? So it has a helical structure. Okay, its molecule have a helical structure. So if you study some biology or even in chemistry, biochemistry, you will know, you will see the chemical formula of this molecule, sugar, sucrose, fructose. They have a helical structure. Okay, so they are like this chain of helical structure. And as we discussed, why polarization happens, right? Whenever you have some chain of atoms arranged like this, then you get polarization. So that's how this chain of molecule interact with the light wave passing and rotates it. Basically it introduces some phase which is different for right circularly and left circularly, because it is helical. So it will affect so your right and left circularly polarized light is going like this, right? So this so that's why this helical structure affects this kind of wave. Okay, differently. So we should not go to the detailed structure of this molecule and why dextrorotatory rotates it like this and that. But if you ever study the biochemistry of this sucrose, fructose, you will have some idea. Okay, but it's very interesting. So yeah, that is, and okay, there is a empirical formula of this angle. It depends on, so okay, like we mentioned, it depends here on the difference of the refractive index and the distance. Okay, so that means it is proportional to, this alpha is proportional to length. Okay, length of the medium, and this refractive index, this difference of refractive index, it comes into play in the concentration of the liquid. Okay, so C. Okay, because if you have more concentration, then this angle will change by more. Okay, so basically, yeah, this is how the refractive index manifests here. And there is a proportionality constant, which is called the specific rotation. It's given by this symbol. Okay, so this is a formula that is used while solving problem. We'll solve one example on this. So this is basically a constant which is called specific rotation. Okay, so this is an empirical formula. So this is the formula that we have derived through mathematical, logic. But in principle, in experiments, like if you take a sugar solution in a bowl like this and you pass light through this, you will observe, some angle of rotation. Okay, and that you can uh, calculate using this formula. Okay, so you need the concentration of this solution and this length. Okay, and the specific rotation is constant for different solutions. So we'll solve one example based on this. Okay, so do you have any question or doubt in this concept? No?
Yeah, I did not understand properly about refractive index. You are saying this is refractive index.
Sorry?
So
Yeah, refractive index.
I did not understand properly about that.
Uh, you mean?
Like you said, different refractive index.
Yeah.
So where is?
Oh, okay. So this and this, right? Why we have different refractive index for right and left circularly polarized light, right?
Yeah, yes, sir.
Yeah. So that is that is what we have, right? In a like when we were studying this, basically by refraction, double refraction thing. We saw that NO and NE. So ordinary ray has different refractive index and extraordinary ray has different refractive index. So similarly, this right and left circularly polarized light, when it is traveling through a medium, okay, and this medium, as I told you, it is very special. Okay, it has this helical structure. So this helix is either right-handed, so it is like this, or either it is left-handed. How do I draw it? Like this. Okay, and and if you have a circularly polarized light in left and right direction, so circularly polarized light in a right direction is like this, right? So it's kind of, so it, if it is right-handed, it affects it, and a left circularly polarized light goes like this, so it affects these two differently, right? So that's why you have different refractive index. So it slows once, one of them it slows down, another one it speed up. So that is what refractive index is, right? So that's why it depends on the medium, which kind of medium you have, how it affects the light that is traveling. And since our light here is linearly polarized, which is made up of right and left circularly polarized light, which behaves differently in this medium. Okay.
Okay, sir.
Yeah. So this is not a very accurate picture, just to understand, just to get a feel of it. Okay. Okay, so anything else? Okay, if not, we can go through some examples.
Yes, sir.
Okay, so yeah, just as a revision of all the concepts, I have put some examples from last session also. Okay, so first one is this one. So yeah, this is a simple one. So in birefringence, how do positive and negative crystal differ in terms of refractive indices? This we discussed, right? So which is the correct option? Can you tell? So we had positive and negative crystals, remember?
Option A.
Option A, positive crystals have a higher refractive index for the extraordinary ray compared to ordinary ray. Okay. So yeah, positive crystals, we had this condition, right? You remember? And for negative crystal, we had this condition. Okay. So yeah, option A is correct. Then we can go to the next. A left circularly polarized beam, wavelength is given, is incident on a quartz crystal of thickness given. Assuming NO and NE, the introduced phase difference is. Okay. So this is very simple. What is the formula for phase difference? It was 2 pi by lambda NO minus NE into D, right? So everything is given here, 2 pi by lambda 5893. This is in micrometers, so this is in meters. So one thing you can notice here, the quartz crystal, it is a positive crystal, so that's why you have Ne greater than No. Okay. So that means okay, so this will be 1.54 something 1.55, and then the distance is 0.025 into 10 to the power 3 meter. So you will get a negative value, correct? But it doesn't matter because we are looking at the difference, right? So phase difference is always you can take the mod of it, so it's a positive value. Okay, so if you calculate it, you will get 0.74 pi. So B option is correct. Okay. Then okay, next one. So consider a plane electromagnetic wave propagating in a crystal with its direction of propagation making an angle 45 degree with the optic axis. Assuming NO this and NE this, the phase velocity of the extraordinary wave. Okay. So yeah. So phase velocity means basically it is asking the velocity of the extraordinary ray. Do you remember the formula? 1 by V RE square was equal to let me see, sine square theta divided by c by NE square plus cos square theta divided by c by NO square, right? This was the formula. So this you can take square root, and 45 degree means sine theta and cos theta both will be 1 by root 2, so square will be 1 by 2, and any square and NO square you can take above, so NE square by 2c square plus NO square by 2c square, and if you put NE and NO and calculate, you will get 4.42 something, and here you will get under root 2 by c, so the velocity will be under root 2 c divided by 4.42, which will be equal to 2.02 into 10 to the power 8 meter per second. Okay, this formula I have discussed, you can check. Do you remember? For extraordinary ray, the velocity is given by this formula always. Okay, so okay, then we can go to the next one. Here it is given an isotropic medium is characterized by NO this, NE this, the refractive index of an extraordinary wave propagating at an angle of 60 degree to the optic axis. Okay, so we need to find the refractive index of a extraordinary wave propagating at an angle of 60 degree. Okay, so now you see this problem might seem little confusing, but okay, so here one refractive index is given NE, which is 2.9. okay, but this NE is the intrinsic refractive index of the medium, but when you have a extraordinary wave, which is and we know that the extraordinary wave, I mean the refractive index for the extraordinary wave depends on the angle to the optic axis that it is traveling. Okay, so sorry, the velocity of the extraordinary ray. So this formula, what it tells you is that it depends, sorry, the sine square theta, the velocity depends on the angle as well as the refractive index of both ordinary and extraordinary. So theta, you remember, theta is the angle that the ray is making with respect to optic axis. Okay,
Yes, sir.
so and now we know that velocity is given by c by n, right? So this is the refractive index that we want. Okay, so you can put here, so basically maybe yeah, you can simplify this. If you put c by NE, so it will be NRE square by c square, and this you can simplify. C square get cancelled from both sides, so NRE will be equal to NE square sine square theta plus NO square cos square theta. So you when you put everything, theta 60 degree is given, NE and NO is given, you will get 2.82, which is 2.81 something. So yeah, D will be the correct option. Okay, so yeah, this is this you have to keep in mind. So this formula is very important. Okay. Okay. Any question? So you remember, like, so what is the optic axis? So along the optic axis, the velocity of both extraordinary ray and the ordinary ray is same, right? It is given by C by NO. But as our wave deviates from the optic axis, this formula comes into play. So always remember. Okay, then we can go to the next one. So here it is asking the thickness of the wave plate required for operating wavelength of this when it is made up of quartz with NO this, NE this. Okay. So for a half wave plate, what is the phase difference? Pi, right? So, and we have the formula for phase difference, 2 pi by lambda naught NO minus NED. So put pi here, NO is given, minus this D. Okay, you can calculate the distance. It will have a negative sign, but again doesn't matter, because you can take the mod of it. Okay. So yeah, you can do this calculation. I don't remember now the answer, but it's a simple formula you can apply. And similarly for the quarter wave plate, you can use phi equal to pi by 2. Okay. So this formula is again very important to keep in mind. Okay, these are very simple ones, just to recap. Okay, if there are no question, we can go to the next. Yeah, here you now have the quarter wave plate. So same formula you can apply here, 2 pi by lambda NO minus NE. But now you have calcite, so it has NO is greater than NE, right? So you can put pi by 2 here, 2 by lambda NO minus NE. You can calculate in the similar way distance. Okay, these are very simple ones. So no, okay, so I have put one problem based on this rotation of planar polarization when a linearly polarized wave travel inside a solution. So this type of problem you will have in an exam. Okay, so what is given here? The specific rotation for sucrose dissolved in water. So sucrose, as I told you, it's basically sugar, 20 degrees Celsius. So temperature is given, but we don't need it. So specific rotation is given, this alpha, which is 66.5 degrees, okay, per 10 centimeter of that of the path traveled, and for concentration and per, like we can write per 1 gram centimeter cube of solution. Okay, so this is basically that. So the dimension of specific rotation is basically this. It's radian per unit length. So per unit, I mean here it is centimeter per unit meter, and it is per like here you can have in, oh sorry, what is happening? What is happening? I don't know. Oops. Something has went wrong with my iPad. Wait a minute. It is doing this. I don't know what happened. Let me try to open it again. Oops. Oops. Sorry, I don't know what is happening. Yeah, no, it's fine. Yeah, so okay, we know the formula of rotation. It was this into length into concentration. So from here you can guess the SI unit, like unit of this specific rotation. It is basically angle, like radian per unit length into kg meter cube. Okay, so this is the SI unit. So that's why it is it will be always given like this. Okay, so here it is given per 10 centimeter of length per 1 gram per centimeter cube of concentration. Okay, so okay, yeah, so concentration is basically kg by volume here. I mean mass by volume of a solution. Okay, I mean so mass is here for the solvent and volume is for the solution. Oops. Mass by volume, this is the solvent. So solvent here is the sucrose, and if it is dissolved in water, it is the solution is your water. Okay, so this is how we define concentration. Water or any solution you can have. So so everything is given here, but we have to look carefully. So okay, so formula is this. So length here is given. So length is what? 1 meter of the tube here. Okay, and it contains 1000 centimeter cube of the solution, of which 10 gram is sucrose. So concentration is basically 10 gram divided by 1000 centimeter cube. Okay, mass of the solvent divided by mass of the volume of the solution. Okay, so this is given, and specific rotation is given. So how do we write it? So 66.45 degree. Okay, it is per 10 centimeter. So let's divide it by 10 centimeter per 1 gram per centimeter cube. Okay, so and then it is multiplied by 1 meter into, so 1 meter you can change into centimeter because everything is in centimeter. So you have 100 centimeter, and then you have 10 gram divided by the 1000 centimeter cube. Fine. So as you can see here, all the these grams and centimeter, they will cancel out. Okay, so it doesn't matter, you can you don't need to change it everything into SI units. You can keep this, and so I mean from here you can see, because there is only 66.45 is there, and there is no other, everything is 1 1 1 1, so you will get this answer, so 6.645 degree. So this is the change of the angle of polarization or orientation. Okay, so yeah, you have to I mean it's very simple, but just you have to look at carefully what information is given and how to use it. So yeah, that was it for today. Okay, so let me know if you have any question or any doubts or confusion from today's, and any earlier concept or discussion, because I think we have some time, so we can discuss if you want. Or any general thing if you want to discuss, that is also okay. So maybe I can start. So so both of you are in bachelor's, or you're doing one of you are in master's?
No, sir, bachelor's.
Okay, so BSc physics, right?
So I'm doing a BTech, but I'm really interested in physics. I wish to do an MSc later.
Okay, so you're doing BTech in which subject?
Electronics and communication.
I see.
EC.
Okay, it is that is great. So you're in final year or?
No, sir, pre-final year.
Okay. Yeah. You can switch to masters. So there are many exams you can write. There is there is one called, I mean you must know that these, right? IIT JAM is there. You can write GATE also. You can write JEST. Yeah. Then there are other exams you can write, like there is a, I don't know if it happens or not, there is something called INET. So if you are interested in astrophysics or cosmology kind of thing, you can write this exam. So this IUCAA and NCRA TIFR take this exam. Okay, and this is there, and then TIFR take its own exam, GS exam it takes. So these options you have, these exams you should write if you are looking to go in physics in higher studies.
Yes, sir.
Yeah. So I mean this is the most simple one. IIT JAM is simple. Then GATE is GATE you can GATE you can write after BTech, but I don't think you can write GATE after BSc, right? I think so.
I don't know, sir.
Yeah, GATE you cannot write after BSc.
There is also GATE physics. I don't know if BSc students can get that.
Which one?
BTech. GATE physics.
I'm talking about gate physics. Yeah, yeah. But yeah, for gate physics, I think BTech is required or MSc is required. But for
Okay.
IIT JAM, BSc and both BTech people can write it. JEST, both can write. So JEST is for research institutes in India, all over India. TIFR is also included here. IIT take from these two. Okay. Then some research institute take also from GATE, but mostly from JEST. Then INET, I told you these two take, and TIFR GS is for TIFR, obviously. Other than that, I don't. Mm, I think for NET JRF, for BTech people, you can write NET JRF after BTech. I think that you have to see. Also, one advantage for BTech is that you can go to direct PhD programs. I don't know if you have heard about it.
No, sir, I don't know.
There are
MSc is not required.
direct PhD programs in IITs, but I think there are some requirements. It depends. Where are you doing PhD or something? I don't know. I don't. Yeah, you can check out what are the options there. But yeah, these are the exams that you should prepare for. Uh, so for me, for my case, like I can tell you my scenario. So I cleared IIT JAM after BSc, and I studied masters from IIT Kharagpur. Okay, and then I gave after my MSc, I gave GATE, JEST, NET, JRF, everything. I qualified all of them. I had good rank in NET JRF, not so good in GATE, and not so good in JEST. But yeah, in NET JRF, I got a pretty good rank. So then I took admission here at IIT Madras in PhD program. So that's how my journey was. So yeah, IIT JAM is also good option. You can first do your masters, and then you can think about whether you want to go for PhD or you want to go for some other kind of some industry or something else. That you have an option. Okay, so
Yes. Are there any resources to study for IIT JAM and GATE
uh,
for?
I'll say stick to your standard physics books. So um, yeah, in IIT JAM, mainly the questions are asked from these quantum mechanics, electromagnetic theory, thermodynamics, and statistical physics. I mean, there are 8 9 topics, right? So
Yes, sir.
there are standard books for them. First, you have to go through basics that okay, you are able to understand the concepts, but you don't need to dive deep into the concepts for IIT JAM because the questions are very simple ones. They will be just on small formulas, uh, not that for example in JEST the questions will be very conceptual. Okay, the only formula will not work. So here you have to go little deeper into the theory. But for IIT JAM, rather than going deep into the concepts, you need to solve problems very fast. Like there will be, you need to practice problem solving. Okay. So I'll say that first go through the previous year papers for them. Okay, that is the best thing to do. Previous year's papers. Okay, and go through them and try to solve them, and based on the questions asked in previous years, you can study the theory about it rather than studying the whole theory and then solving the problems. You can first okay, first learn the basics, then you go to the previous years. Okay, try them out if you are able to solve them or not. If you're not able to solve them, then go back to your go back to theory and study the theory on which the problem is based. Okay, that will be a smart way to do. Like, that's what I did for IIT JAM. So I studied for like 2 months only for IIT JAM, self study, that's it. I did not took any coaching or anything, but yeah, I had, like, I studied the basic books well, and then I just stick to this previous year's papers. And also these there are some, you know uh, this test series are there, right? I don't know nowadays
Yes, sir.
if it is there or not. So you can join the test series, uh, and that will be a very good thing to do, because that will teach you the time management, and problem solving skills will enhance. So joining the test series is a very good idea. That's what I did. I think this is what helped me most. So yeah, that way you can do, but you still have time. So first you learn the basics, go through all the topics that are there in BSc Physics. You don't need to go through all the topics, just print out, download the syllabus for IIT JAM or GATE. You can see the topics that are there, you can study them. So any standard book you can pick, whichever you are comfortable. There are many books are available, but concept wise they are all the same. So just whichever you are comfortable with. If you can ask me which book I followed when you start to study a topic. I can let you know. So yeah, you can ask me. I can give you, I don't know if you have my mail ID. I can give you my mail ID, so I can tell you the name of the book which I followed. Okay, I have written my mail ID in the chat. You guys can contact me anytime. Okay. Anything else?
Can we contact you for doubts,
Yeah,
like
yeah,
further
yeah.
doubts
Sure, sure,
in
sure,
this
sure.
topic?
Yeah, in
Any other?
yeah, anything. If you face any problem, you can contact. I will try to help.
Okay, sir.
Okay.
Yes, sir. Thank you.
Yeah. So, okay. So then, do you have anything else to discuss?
Yes, sir. I wanted
Okay.
to say something like I did give JEE
Mhm.
mains and advanced,
Okay.
but like yeah, so I was getting NIT Agartala, okay,
Okay.
and I was confirmed that like I have to go in pure sciences, not engineering.
Mm-hmm.
But it was a BSMS integrated degree, so I did not choose that.
Okay.
But 5 years now.
Yeah, yeah.
So I did not choose that because like my parents did not that it was so confusing, okay.
Okay.
And but now it's my second year in my it I am like I study in a it's a just a state university
Okay.
in Haryana.
Okay.
But I think now that I should have gone to NIT. That should have
Mm-hmm.
been very
It's okay.
better
See,
than this
that
one.
is not an issue. You can like, you can still, like I told you, you can write the IIT JAM and you can go to IIT for your masters. So uh, I think also it doesn't matter. Okay, the institute doesn't matter much. I'll say. It
But
matters
sir,
at some
the
point, but yeah, I don't know which university. Like, it's how are professors there? Do they teach well, or?
yeah, they do teach well, but like my classmates, they are not either. I don't think they are as dedicated like
Yeah,
me
yeah. So
in.
yeah, in these colleges, most people are there for only the degree, right? They will do something else. They will not go into physics later. So they are just there for the degree. So they will not focus much on physics. So yeah, I can understand this kind of
I
situation.
face, yeah, sir, I face a lot of problems, and
Mm-hmm.
financially also I face problems. I think if I was like, I might have gone like, means
Mm.
like, if I did go for NIT or IIT, I may have uh, won a scholarship or something.
Yeah,
But
yeah, no,
here
no.
I
See,
have
whatever
no
happened
scholarship.
is happened. Now you can't change that, right? Now you have to focus on what you can do. So you can try for these exams, and then you will go to a better place, and everything will be fine. So you have to just work little hard, and these exams are not that difficult if your basics are clear and you can solve problems. That's it.
Yeah, okay. I was asking if they're like, I can work with, yeah, that internship, etc. I like, I try to
Internship,
do
see,
that now.
yeah, internship you can also do, but that will not help you in exams, okay? Like in these competitive exams, that if you are looking for cracking these, internships will not help you, okay? So
Oh,
it's better to do internships and projects in masters, where you have to gain some research insight, so that you can decide for yourself that you want to go in research or not. But for now, for doing masters, you don't need to do internships, right? I don't know how it will help you, because in these exams, I mean, people, they will not ask anything related to your internship or research projects that you will do.
yeah,
So
not for exam, like for like my course and all.
it
Um,
it will
further
not.
studies.
Yeah, further study that you can do in master, but for now, if you have time, like if you have summer vacation or winter vacation, you can prepare for these exams, right? That will be a better use of time rather than doing projects, too many projects or anything. You don't need that. I don't think you need that in bachelor's. You first need to get to masters, a good institute in masters. So, and after that, if you because if you get into a IIT and NIT, then you'll have a plenty of opportunity to do projects. You can approach professors in your institute, and they will easily take you, and there will be no issue.
Yeah, okay, okay.
So I'll say that you first get into a good institute, try for these exams, and then you can see what you want to do. You can now,
Yeah,
if you get into good institute like IITs, you can also sit for placements. People like in my batch in MSc, people also went for placements in many areas. So yeah, if you like, you can go for research also later. So it depends, but yeah, first thing is that you need to get into a good institute. So I'll say, I mean, I'll suggest to focus on that, but yeah, it's your choice.
okay, sir.
Hmm. Okay. Uh, yeah, and one thing also I would like to say is that I don't know, if you ever if you ever think about doing PhD in India, just remember that uh, you have to choose your guide very carefully, okay? So but that, I think you still have time to think about that, so I will not tell you much about that. But yeah, mentors do matters, okay?
Yeah, okay, sir.
Mm. Okay, yeah, anything else? So I mean, I really liked that you guys joined every session. Only two of you have been consistent, and so from my side, I really liked it. otherwise what happened, I mean, I have conducted many you know these kind of live sessions before in my PhD, but sometimes, I mean, I, like I have to teach myself. Like there will be no student joining, so that time it's little difficult. And so I really thank you guys for joining all the sessions. I really enjoyed, and I also learned many things, because I have forgotten many things about wave optics, and then I had to teach myself before teaching you. So in this process, I learned many things, and yeah, it was fun. And yeah, this is the last course that I will teach in PhD. So my PhD is almost over. This is the last semester, so yeah, it was nice. It was a nice end. Okay, so yeah, thank you for joining. Anything else want to discuss? We have time.
Yeah, so we don't like, I don't have some questions as of now, but if you tell us something that like from your experience, it would, I am here to listen.
My experience in research, or my experience in bachelor's masters.
Bachelors, yeah, like what's helpful
Yeah.
and what should not,
So.
what should
Mm,
avoid.
yeah. So that, like I told you, in bachelor's, see, I'll guess that the semester exam, there's you can study for like 4 5 days, and you can pass. You can get a good marks there, right? So you have plenty of time in your semester, uh, other than other than to study for the exams in your of your semester, right? So I'll suggest that in that time, obviously, you have fun, because this is the time to have fun, right? But other than, I mean, the rest of the time that you get, you can, yeah, you can think about these competitive exams. You can start preparing for it. Uh, like I did not do it in my in earlier. I So like I said, I prepared only for 2 months, but I got lucky. Okay, but you might not get lucky. So that's what I'll suggest, that start preparing for it early on, so that you can get a good marks. And but yeah, it is very important also to enjoy this time, to have fun, to make friends. That also matters. uh, yeah, so keep a balance of everything, take care of the health. uh, Everything matters, yeah. So yeah, that's all what I will say from my experience. And you should not have regrets of what decision you took earlier. You still have a long journey, so you can uh, yeah, you will have many decisions to make later in life, so don't worry. Okay, so I'll not preach anymore. I might bore you. uh, so yeah, anything else, any question? So you can contact me if you have anything to ask, any problem that you face. I will try to help. If you want to study any topic, any subject, you want to know which book is better, like which book that I followed, I can tell you about it. So yeah, you're welcome to ask me in the mail.